and welcome back. I am so glad that all of you could stay with us in part 2 of our session on heat pump water heaters in restaurants. In this section, we will focus on innovation, challenges, and the solutions. And now we have with us these panelists. We have Mike Hlavay, president of Sierra Valley Mechanical. We have Bart Ransom appearing by video, who's the sales manager for Colmac Water Heat. And Tim Rooney is with us, senior project engineers, systems, A.O. Smith. And we have Noah Gabriel, project manager with New Buildings Institute. And I'm your host, Susan Harris with New Buildings Institute. And I know this is a repeat for those of you who have been with us for the entire session, but in case anybody is new to this event, just getting started in the second half, I'll just run through a few highlights. This is a week of Heat Pump Water Heater Day, and so we have lots of resources that you can use to get involved on social media, as well as a lot of special events all week long, culminating in a full day on Thursday. You can make your own market transformation badge. This is mine that I made with a picture of me in front of a commercial heat pump water heater that's in the basement of the PAE building in Portland, Oregon. Please check out the full program if you haven't already, and sign up for more events. If you are posting on social media, please make sure you tag your posts with these hashtags so that we can find your posts and put you in a drawing for a heat pump water heater of your very own. With a generous donation from Bosch and Ariston, they are covering the cost of a heat pump water heater and installation. It's amazing. We want to say a special thank you to our supporters, which include for this event, CETA, California Energy Design Assistance is a statewide utility incentive program. They also have a presence in other states. I just learned on the first part of the session. Please follow up with Tina Hendricks to learn more. And so here we are. We're going to get started with our panelists. And I'm going to have Noah kick us off. He's going to tell us about some field studies he's doing. Noah, over to you.
Awesome. Thanks a ton, Susan. I'll share my screen right now. Presentation mode. How's that look?
Looks like it's still loading. There it is. Now you're up.
Perfect. Okay, sweet. Well, yeah, thanks again for having me on here. I'm Noah Gabriel. I'm a co-worker on the same small team as Susan. I'm a project manager, and I lead a whole bunch of different field studies focused on heat pump water heaters throughout California and the Northwest primarily. So yeah, tough act to follow if you were there earlier. Great job to Richard and Amin. They provided a ton of great insights, and I'm trying to not reiterate too much of that content, but we were kind of in the theoretical realm and calculating inputs and outputs before, and now we're getting into some nitty-gritty of real-world field study results. If you get this title, kudos to you. This song has been living rent-free in my head for the last year or so. So it's like, oh, it's heat pump water heaters, hot water in a quick service restaurant. So just kind of struck me funny there. But anyways, let's get into it. So current state of the market. So for small commercial buildings, think offices, grocery stores, really anything that's kind of on the small business end, so not industrial, but also not residential. And this has almost been what I want to call the forgotten middle child of the water heating market. And these are often served by inefficient either electric resistance or gas-fired units. As we already know, you're maxing out at 100% efficiency for electric resistance, and probably more like 90, high 90s, usually more like 70s or 80s for gas units. So there are a lot of energy savings available, and definitely cost savings, especially dependent where you are in California or elsewhere. So these heat pump water heaters often fall into kind of two main categories, specifically for single family homes and multifamily. you're often getting these small unitary systems. So think 50 to 80 gallons, often less than 1 ton or 12,000 BTUs of capacity. And then on the other side, with these huge, super, expensive, complicated systems that are awesome for multifamily buildings, but, kind of overkill for a lot of the other small commercial applications that we're looking at. So luckily, some great alternate solutions do exist in the form of these small commercial heat pump water heaters, kind of like you saw in my intro slide, that CHP 120 from A.O. Smith, or split systems like the ones produced by Sanco. So you can see an example of the tanks in this picture. So those are usually around 100 to 200 gallons of total capacity, depending on your setup, and often around 4 or more tons of heating capacity. That means about 40,000 to 80,000 BTUs, depending on your temperature inside and outside. And so I'm leading a field study right now in collaboration with Ecotope, and we are installing monitoring and verification equipment at a couple dozen sites, a variety of different small building types throughout California and the Northwest. And some of those that I'm going to get into in a bit are quick service restaurants, a couple grocery stores, and a diner. So I'm going to get into the nitty gritty of the restaurant component here. So already mentioned the system types, and we also have the exciting opportunity to test some new prototype units too. So a couple new heat pump water heaters that have not even hit the market yet, including a new split system. So why is this study needed? Why are we going through this effort of monitoring all these heat pump water heaters in the field? Well, performance data is limited, and often, no knock against manufacturers, but performance in the real world is not going to be as good as it is in the lab. Think about, for example, an EV driving test, right? Those are going to be performed on an open highway. You're keeping a easy speed, no traffic. They might say, oh, you get 400 miles, right? In reality, you might be getting 250 because there's stop and start traffic. There is, just kind of imperfect road conditions, all of that. So in reality, performance is a little lower. Same thing is happening here. Lab tests are usually about 80 degrees ambient and a pretty low input water temperature. So of course, in the real world with varying conditions, things like recirculation, performance is going to be often a little bit worse, but still good. So we wanted to test that. Okay, is the performance a lot lower? Is it a little bit lower than rated specs? Wanted to figure that out. We also wanted to know more about installation and sizing best practices, and then any issues as it pertains to restaurants. I think this was mentioned a bit earlier, but think about all the things that are going on in a restaurant. There's grease, there's smoke. Those could cause some potential issues. So we wanted to see if that was, kind of a big deal or not. And we're going to assess a few things. So energy performance, what's the coefficient of performance? How do installers like these? And then how do users like them? And then over on the right-hand side here, you can see an example of some rooftop mounted Sancos. So that's just an example here. They're going to be disconnected from the tanks, but this was at a diner that we're monitoring in Sacramento. Not going to belabor these points too much, but basically for energy, we're looking at COP. We're doing M&V for 6 to 12 months, depending on the site. So it'll be a good chunk of data across a variety of seasons. And we wanted to pay special attention to how much electric resistance is being used versus the compressor, because if it's only electric resistance, you're going to really cap out that efficiency at around 100%. And not get the most out of your heat pump. So want to make sure it's mostly compressor use. Not the primary goal here, but did want to chat with some contractors and also, of course, interview folks for user satisfaction. Things like, are you getting scalding? Are you running out of hot water? So far, from all the managers I've spoken with, there haven't been many issues in the restaurant so far. A couple things to note though. So especially for those integrated units like the CHP 120, you do want to have enough cubic air volume, right about 3,200 cubic feet. So that's a pretty decent sized room. Otherwise, you can overly cool off the space, and that will trigger more use of the electric resistance elements, and then decrease the efficiency of the system. I did speak with someone with a commercial kitchen who kind of ran into that issue, but luckily they were able to do some ducting and bring in a whole lot more airflow, and then the performance was perfectly solid. So just a good thing to keep in mind. And if your space is super small and you can't duct it for whatever reason, there are split systems on the market and new split systems coming out soon. So good thing to keep in mind there, but I have not heard about scalding and not so much in the way of hot water runouts either. And you'll see some results coming up. Just some other metrics we were looking at. You can see a flow meter there we were using to detect the hot water flow. Wanted to look at some codes and permitting, basically like, are these hard to put in? We haven't had many learnings there yet, but in the final report, we should definitely have some. For site recruitment, we have 4 restaurant sites installed so far and a good bit more recruited. So we have a diner, a McDonald's, and then 2 grocery stores that have a lot of cooking and baking going on in them. And the cool thing about the study is the data is flowing directly into a dashboarding app made by Ecotope. So comes into these nice visuals automatically. And we're collecting real-time power, flow of hot water, energy use, and then inlet and outlet temp, in addition to some other variables. So just a couple more minutes here. I want to stay on time, but let's take a look at some early results. So Kroger here, you can see that the coefficient of performance is okay, hovering around 1.5 or 2. You can see that their water use is pretty variable. So, don't have early results there on why that could necessarily be a little lower, because we're studying a food for less and the coefficient of performance is actually higher, more around 2. Both of these sites have quite a nice setup in that they're co-located near a bunch of cooling equipment. So there's a lot of waste heat flowing in. The temperature is sticking between 70 and 80 in these big rooms. So generally speaking, we would expect performance to be even a little bit higher, but we'll do some further investigation into the install and potential reasons why that could be happening, because we're not seeing a whole lot of electric resistance use either. So could just be the variable demand here on the system. And you can see some really high hot water use days going all the way up to 700 gallons. So that could also be taxing the system. Could also be a recirculation thing where the recirc load is kind of putting some strain on the compressors. For both Kroger's, though, we did see some pretty clear performance that it's outdoor air temperature, but it's really the air temperature in the rooms here going to lead to way better performance. So when you do get all that waste heat and it's about 80 degrees in the room, you're getting closer to like a 2.3 COP. So that's pretty darn good. McDonald's has been a little on the lower end, still pretty decent, around 1.5. There is continuous recirculation there. So we think that is what's bringing down COP a little bit. Continuous recirculation is going to be common in restaurants. And the reason that brings down performance a bit is because it's basically destratifying the tank and returning warm water as opposed to cold water that heat pumps excel at heating, and that's triggering a lot of electric resistance use, as you can see there, and also pretty high daily load. Last but not least, we have Lil Joe's restaurant. Quite good performance here, around 3 COP. They do have a little lower daily water use with some outliers, so bit of a easier load on that system. Also some really good temperature conditions so far. This is in a warm climate and we've only been monitoring during the summer. So the beginning temperature is about 60 to 100 degrees outside. So that's really optimal for performance there. Like we were showing previously, high temperatures are going to be good. Last couple of notes here before I wrap up. I did see after returning to a site that was the water heater was located in the restaurant, and it did see some buildup on the fans. So definitely a kind of good observation there that all that particulate in the air can clog things up a bit, but haven't seen any failures. Some exciting next steps here. We're going to be testing some new prototype units. I think the performance is going to be excellent on those. We're adding some more sites. and we'll have final results here at the end of 2026, but I'll be presenting further preliminary results at the Hot Water Forum in just a few months here. So definitely stay tuned for that. And thank you so much for listening. And excited to share final results. Cheers.
Thanks so much, Noah. That is really cool to see some of those examples from the field, and we look forward to seeing the report in 2026. Quick question for you. Will you be looking at the effect of a 120 volt heat pump water heater in some of these settings?
Not yet, because I think for the most part, unless you're in a really small cafe, I don't think 120 volt heat pump water heaters will quite have enough capacity to meet the load. So from a couple of the graphics I was showing, right, it's usually like 300 to 700 gallons per day. So that's quite an intense water load, and that's kind of why I was saying it's like 4-ton plus systems for the most part to be able to produce that much hot water. So again, maybe in like a tiny cafe, we could see some 120 use. Could be interesting.
Okay, thank you for that information.
Of course.
And we'll hear from Mike. Mike, could you come on camera, please, and talk to us a little bit about your work to install Sanko systems in commercial kitchen? And I guess it's possible that Mike had to step away from his computer for a moment. So what I can do is I could continue on, and I have a video to share with you from Bart Ransom from Comac Water Heat. He was traveling and wasn't able to join us today, but he took some time out of his busy schedule with me yesterday to do a little presentation, and I recorded it. And so just one moment while I get that uh, recording started.
Hi, my name is Bart Ransom. I'm the sales manager with Colmac. Transition from Colmac coil to Colmac water heat. Today we're going to talk about large-scale commercial kitchens with heat pump water heaters. Colmac's been doing this for decades, actually. We've got hundreds of applications in large-scale kitchens and continually quote them on a regular basis. So what we're going to talk about today, we're going to talk about the fundamentals of the heat pumps and their applications and our variety of solutions and how we approach these issues. So in large-scale applications, we're talking about convention centers and hotels and schools and hospitals and elder care, from prisons to dormitories to full-service office spaces. So there's a variety of applications that present themselves. Primarily, we're approaching that large-scale application. So what kind of considerations of heat pumps are there in commercial kitchens? What types of facilities are actually using the commercial kitchens? So the needs of a facility can vary greatly. They can or will need to be able to provide variable timeline food scheduling, as well as having all of the application heating for the hotel itself. So there also may be applications where schools or high schools or hospitals are become public service distribution points, where in an emergency or something there may be an additional load that may be having to be served by that particular application. So we have to take these things into consideration. The changing needs of the customer must be considered in the application. So as we go forward, What type of services are provided in a large commercial kitchen? Is it full service kitchen? Is it a reheat facility like many of the schools are today? Is it a combination facility that may be doing both? What types of foods are in that full service menu restaurant? They may have several different diverse offerings that require speciality of prepared foods. There may be baked goods or a sauce house or grills or all different preps and varieties that must be considered in the kitchen composition. The tools that the kitchen would require may require more water consumption or more cleanup schedules. So what are the schedules of the kitchen? Is there prep work and cleanup that has to take in effect prior to or after that's going to make it run the entire water load? So how many kitchens are even on site? And so in the longer bit or larger buildings that we see quite often, there may be 3 to 4 different restaurants as well as a convention load. So we have to take those all into consideration. And are their schedules alternate from what a standard kitchen would be? So that when this happens, we have to take that into consideration. So what's currently providing that hot water for that service? Say, for example, if we're going into a retrofit, and we do this quite often where we'll go into older buildings that have a boiler configuration to where they want to be off of the fossil fuels, or they want to have a dual fuel opportunity. So we'll have to take those considerations, and how do we integrate into that system with the newer technology? So moving on with that. So is it a retrofit application or is it a new facility? These are things that we need to know as well. So what does the mechanical room consist of? Is there boilers? Are there storage tanks? Okay. Is there a pumping system? Are there multiple distribution paths for multi-temperature loops? Okay. Where is the facility located? Is it in a region that's exposed to wide climate variances? What is the designer's intention? Is it a full heat pumps, multi-fuel, redundant sources? Where will the equipment live? Will it live indoors or outdoors, or a combination of both? So how do we this team that will take in all of these considerations previously outlined? We'll design a load profile for that particular facility's custom needs. We'll scale the heat pumps for the application for a recovery period, considering the climate zones that the equipment will be in. So, well, consideration for the design needs would be the integration or the implementation, and we would recommend what type of equipment we would be able to look at for particular climate zones. So we provide system and unit performance estimates based upon the input provided by the customer for the environmental considerations. We confirm the sequence of operations and the control methodology of whether it's a Colmac provided system or whether it's a system integrator coordination. We'll review the final design of the heat pumps and the application compatibility, and we'll work with the design build team during the commissioning and startup to be able to make sure that that schedule or that system works out well for the end user. Sometimes that can be a quite complicated review process. So primarily, that's exactly how Colmac approaches commercial water kitchen or large scale kitchens. And that's how we go about doing business.
Thank you so much, Bart. This is really impressive. It's great to hear about Colmac's approach to this market.
Well, thank you very much. We look forward to serving customers in the future.
All right. And again, I will put our website and share the link. Apologize for any sound issues that may be coming across the lines. And next we'll have Mike joining us to talk about his installation of Senko systems. And Mike, would you like to share your slides and talk with us a little bit now?
Hi, my name is Mike Hlavay. I'm with Sierra Valley Mechanical in Sacramento, California. and I am on the installation end. And just last year, the first heat pump water heating system without resistance heating was installed in Sacramento County. And our claim to fame is we were the first ones to ever do it in our county. And I'm going to just show a couple slides of this project. We chose the Sandco. We looked at multiple different projects, including commercial tanked, and there simply wasn't room in this restaurant. It was very, very small. We looked at some higher powered condensers, but the Sandco for this particular project last year in this application was the most cost effective. Wasn't a huge job. It had 4 condensers on the roof. It was just a small diner. We were replacing a 180,000 BTU, 120 gallon tank water heater. Honestly, couldn't tell you if that would meet the health department needs. That water heater had been in for well over 2 decades. It took 2 storage tanks, which you can see to the right. And the permitting process was quite interesting. Our health department sat on our application for 6 months, and it took a little bit of cage rattling, and they finally approved it. And we're in the process of trying to get some help in our area with training for our building departments and health departments. I honestly think they may have just approved this. I'm not really understanding it, but so far this water heating system is being studied. It's meeting all the demands. The restaurant has not had any issues with hot water supply. In our county, this is what our health department requires to determine the use needed. Now, this is, again, a very small restaurant. So if you look at the fixtures, 1 3-compartment sink, 1 single compartment prep sink, 1 single restroom sink, 1 mop sink, and a very small powered, small consumption dishwasher. So the load was pretty minimal. So we currently have about 5 more projects in various stages of permitting and installation. To compare that to this restaurant, it is a Mexican restaurant. It used to be a steakhouse. If you look, the fixture counts are much more substantial, and the load in this restaurant is quite a bit more. It's calling for 386 gallons per hour of capacity. So this one we're currently in the process of working through with the health department, trying to figure out if the number of condensers that we proposed is going to meet their requirements. This is the Sandco system. It uses multiple small condensers. So they are small, but you definitely need more of them compared to some of the higher powered split system heat pump condensers. And they use the storage tank similar to anything else. They do only have about 15,000 BTUs of heating capacity. So pairing them up and sizing them is something that we're all learning as installers. It installs pretty much the same as the previous presenter showed on their slides with their various products and types of equipment. This is a set of plans for another one that we have in process, another restaurant, is what we're required to submit in our area. Obviously, that can definitely vary from jurisdiction to jurisdiction. And having been in the trades for 34 years, I definitely know some building departments are easier than others to work with. But my understanding is no matter where you are in the state of California, if you're dealing with a commercial kitchen, you do have to go through the health department. This one is going to have 5 condensers located on the roof. and we're having to pull a electrical sub panel to the roof to power them. The Sancos in particular are relatively low power, only 7.5 amps per condenser. So they don't add a lot of load. There are no three-phase versions of this equipment available currently. That is something that we have looked at other projects that we could have used three-phase on. This is basically a plan page of what I just showed you. This is our electrical line drawing. Pretty much any building department is going to require you to show the added load. And typically they're going to want calculations shown, you know, that this added load is not going to exceed what's available in the building. And some other things are required. This is our panel schedule where we have to show everything that's currently in the electrical panels and explain how everything is going to fit within the available electric capacity. And then the piping plan, how it's designed, how everything flows, works together. And then those are our spec sheets submitted in the plans. That's really all about all I have to present. We, you know, as you probably figured out, we've only installed one heat pump water heater system in a commercial kitchen ever ourselves. We've installed thousands of heat pump water heaters, including commercial systems, but relatively new to our area. And while we only have one installation under our belt, we're definitely piling up installations and working through them. So that's my experience in installing these systems. And interesting to see a cost analysis. You know, these systems are very expensive, but we do have the benefit in our county and our state of investment by government and for rebates and incentives, and in some cases outright being paid for 100% of the cost by our utility. That certainly makes it easy to convince a business owner to allow this installation. And I think that's about all I really have to share with everybody. Happy to answer any questions.
Mike, thank you so much for sharing your experience installing Senko systems. And I think I heard you say that you have completed the installation of one and you have 5 at various kind of phases of the process. Is that correct?
Yes, that's correct.
Okay, great. Thank you. I think what we'll do is we'll go to our next speaker, Tim, and then after Tim is done with his presentation, I'll ask all of you to come on camera and we'll have some time for questions then. All right, Tim, take it away.
All right. Hello, everyone. I'm Tim Rooney, Senior Project Engineer of Systems at A.O. Smith Corporation. I work on our commercial new product development team, where I focus mostly on heat pump water heater development. And I'm excited to share some of that work today. So my plan for this presentation is to first start off with an overview of the current heat pump water heater offerings that we have for restaurants. And then I'm going to talk a little bit about how our most successful central heat pump water heater for restaurants, why customers like it and why it's found success so far. And then we're going to be, I'm going to be honest about some feedback that we've heard. I think that some of the previous presentations have also touched on some things that could be improved with the current offerings, and then I'll discuss what that means for the future for us. And specifically, I'll be talking about 2 projects that we're working on in the engineering team. So like I said, I'm starting off with an overview of what we offer. On the left-hand side here, we have what we call our emerge-i platform. So we also refer to these as our light-duty commercial. In the restaurant space, this is going to be really light-duty. You can see that the heat pump capacity is only about 5,000 BTUs. So referring back to Mike's previous presentation, that's about a third of the capacity of the heat pumps that he was installing in his application. This isn't an integrated platform, which means that it's all in one. It's all in one package. Limits penetrations that need to be made into the building when installing these systems. But building off of this, moving on to the CHP120, these are a much larger integrated platform. I've heard it called light duty. We refer to it as medium duty, just separating it from some of the heavier duty platforms that we have. It has a 120-gallon storage tank, which is only about 50% larger than the largest eMERGI product that we have. But the main difference from the smaller products is the heat pump capacity. The heat pump capacity is about 8 to 9 times larger than that of the previous platform that I discussed. It also contains 2 backup elements to make sure that if there's a risk of a hot water runout event from just the heat pump, that it can get through those large draws. I'm going to be skipping over this this third section for now and moving on to the eMERGX line. These are our large commercial heat pump water heaters, and these can have capacities up to another 8 times that of the CHP 120. And like I said, we'll come back to this this hidden third cell in a little bit later in the presentation. I think that the basic specifications of the CHP 120 have been shown a few times already today, so I'm not going to spend too much time here. But just a few highlights is that there's about, in hybrid mode, about 83,000 BTUs of total capacity, and about half of that is available from the heat pump itself. And I think this was also shared earlier that there's a 4.3 COP when measured at lab DOE test conditions. And it is available in both 208 and 240 volt AC with single phase. I also do want to highlight that there is a 3,200 cubic foot room volume requirement for this product. So when it comes to applications, we've seen quite a bit of success in restaurant applications with this product. There's a few reasons for this. One of them is that with current CCDEH guidelines, which Amin did a great job explaining earlier today, most jurisdictions will only allow heat pumps and heat pump water heaters to be sized based on the input power. Because these have backup electric elements, those elements are allowed to be used in the sizing calculation, meaning that about half the capacity of the unit can be accounted for, where compared to true split systems, depending on the jurisdiction, they may not even allow this to be installed. Where jobs have mechanical rooms that are large enough to support the room volume requirements or airflow requirements, the form factor matches pretty closely to that of the existing gas tank products that these are often replacing. So it minimizes the amount of plumbing work that has to go in when a retrofit occurs. And then also, if there's some sort of airflow or communication with the kitchen air, the kitchen air is usually warm, and that helps increase the effectiveness of the heat pump. We also support these systems and sizing of these systems through our online sizing tool. I talked before about the different configurations that it comes in, 240 volt, 208 volt. And we also support sizing it just purely on the heat pump only. This sizing tool also adjusts the listed capacity, or the capacity shown on the website, based on the ambient inlet and set point temperatures. So we account for the different performance of the heat pump at different conditions. So now going on to some feedback that we've heard on I guess our whole offering. So when it comes to the CHP 120, we've heard that the backup elements can be a little bit more sensitive than maybe installers and building owners have been expecting. There have been some cases where there's an unexpectedly large amount of backup element use, and we want to make sure in the future that these products, the backup elements are truly backup elements. We've also seen from some third-party lab testing that there's room to improve our tank stratification strategy. And Amin alluded to this earlier. There are some scenarios where the heat pump can lock out when the room gets too cold. When it comes to features and installation requests that we've heard, we've heard that not all sites have enough room or volume or makeup area requirements to support the CHP120. We've also received some feature requests like building management system support and load shifting and demand response capabilities through CTA 2045. And then in a restaurant environment, it's greasy and it's dirty. So we've heard feedback that there are concerns with the current method of mounting the filters. So moving on to the next slide here, I'm happy to say that taking all this feedback into account, we're working on 2 projects to try to address this feedback and improve upon this great base of product that we have. So the first thing here with this refresh for the CHP120 is we are improving the control algorithm. We're making sure that the elements will be used less in the same application, so that they're only used in scenarios where hot water runout is truly a risk, to make sure that they're really only used as a backup and not the primary mode of heating. We're improving the tank stratification that we see in a tank with our control algorithms. But we've done all this with application testing to make sure that we're not affecting the amount of hot water delivered, because we know that hot water runouts are not something that food service wants to see. So we want to make sure that we still provide the correctly sized amount of hot water and the amount of hot water expected when these units are installed. We're also going through the process to making these products NEA compliant. And we are improving filter accessibility and mounting to make them easier to clean in restaurant applications. I also would like to say this is filling in that third box from that earlier slide, that we will be launching a commercial size CO2 split heat pump water heater system next year. This is using the familiar EcoCute form factor, like what is currently available on the market, but this is a commercial version with 33% higher capacity at 6 kilowatts of nominal capacity. Because this is a split system where the heat pump is installed inside or the heat pump is installed outside, it'll be a good alternative to the CHP120 in sites where there's just not enough room in the mechanical room, or bringing in air is really not feasible. And for commercial applications like food service and restaurants, contractors will be able to install up to 32 heat pumps controlled with a single controller and one or multiple tanks, which will give a lot of flexibility to ensure that proper sizing can be done for these systems. And just like the CHP120, this all will be implemented into our online sizing tool, and we have a great application engineering support team at A.O. Smith & Well to support sizing needs. So going back to that original slide here, I just filled in that third cell there with this upcoming commercial CO2 product. So you can see where it fits in the lineup. So with that, I appreciate everybody's time today. I hope you are all as excited as I am about these upcoming product launches. And I'm excited to hear your questions. Thank you.
Thanks so much, Tim. It's great to hear about the offerings from A.O. Smith and what's going to be coming soon. That's exciting stuff. If I could have the rest of the panelists, please turn on your camera and your audio. And we have about 15 minutes for conversation, questions and answers. All right. Well, I did carry over a couple of questions from the first part of our session today. And Tim, I wonder if I can ask you this one question that came up earlier that we thought was a really good one, and thought that you might be able to help with this question. It was about the technology, about the equipment. And the question was, Will heat pump water heaters ever be as fast as electric resistance and still be efficient, like with the right heat exchanger or system design?
I think so there already are heat pumps on the market that can be as large as electric resistance or have the same capacity as the equivalent electric resistance heater. The difficulty is the size or the compactness, because an electric element is, compared to a heat pump, very, very tiny, right? You can, you're probably taking up 20 to 30 times the same volume, even with a pretty compact heat pump design, to get the same amount of heat into the water. There are some, I'll say, long shot technologies that you may see out of universities or national labs that may have the opportunity in the future to introduce more compact heat pump water heaters. But I guess for what's feasible today, it's a little difficult to see kind of the immediate next step to a much more compact system than what's available. Usually, I guess the solution today is to purchase a larger heat pump water heater and put it outside or on the roof, because an equivalently sized or a heat pump water heater that can meet the same capacity as an electric resistance did before is usually going to be much larger.
Mhm. Thank you for that. Amin, would you like to add to that question? I'm not sure if you heard that.
Oh, yeah,
It was-
I 100% agree with Tim. I think the strategy is to just remote the unit. Even if it could be placed inside, you likely don't have the ventilation requirements, right? We can't, we'd be creating like walk-in refrigerators of these back of the kitchen, back of the house kitchens or other applications. And so, yeah, I think we have some great technologies. So when we can put it inside, that 1-for-1 or even slightly larger, right? We can do that, but why not just use that interior space for the storage tanks and remote the outdoor units, which is very much what HVAC systems do. So we're just kind of following along with that.
Mhm. Thank you for that. And then Tim, I have a question here for you. And the question is, does the A.O. Smith 120 use a micro-channel heat exchanger?
Yes, it does.
Great, thank you for that. And we have a new question here. In integrated units, the compressor set point sometimes misses warm incoming temperatures and doesn't turn on. So the tank draws down with warm incoming water and the electric resistance element turns on before the whole tank goes cool. Will your control update accommodate this nuance related to recirc systems? Perhaps a simple checkbox sort of effect with warm inlet water or recirc loop present?
That's a good question, Evan. I don't think we're ready to share any specific details about the algorithms today, but we are aware of that concern. So it's definitely something we're thinking about.
Great, thank you for that. And I wonder, and this is for everyone on the panel, and maybe I'll start with you, Noah. Are there certain reasons that commercial kitchens and restaurants are expressing an interest in this technology? Is there something that is really top of mind for them that you're hearing from them most often? And what is that?
Yeah, a few things. Great question. So I think one is the cooling benefit for sure. Just inside, kind of goes hand in hand with using induction cooktops, right? Is reducing total temperature, reducing kind of potential accidents that occur with natural gas, right? Like just having natural gas in a confined space can both heat things up, also more scalding risks, especially for cooking. And you have a lot less training for restaurants too that have all electric kitchens because you don't have as much, safety training time, which can really cut down some costs. So I've definitely been hearing about that. a good bit. And then of course, rebates incentivize people. So definitely, the more rebates, the better in terms of at least this early phase of adoption, right? I think we're further along for single family homes, but in the case of heat and water heaters in restaurants, I think to convince folks to try something new, getting part of their equipment paid for is going to be a big a big driver there.
Yeah, that's understandable for sure. I mean, is there anything that you would add that you're hearing from this market segment?
No, I think Noah really summarized it well. Yeah, yeah, I'll leave it there. Yeah.
Okay, thank you. And then Tim, perhaps you could answer the question from Bill, who's asking about cold climates, -4 Fahrenheit design. How's freeze protection during power outage done for split systems, Sanco, or the new A.O. Smith split system?
Yeah. So with these types of systems, we actually have a specification, the advanced water heating specification, published by NEA that we reference and can follow. There is a freeze protection test in that specification that manufacturers need to perform in order to be listed on NEA's qualified products list. So there's not in that specification any specific technique we must use, but what we've seen is very common in the industry is anti-freeze valves to meet that requirement.
Great, thank you for that. And then, I mean, there's a question here that I'll check in with you on. It was mentioned about the role of health departments in permitting for kitchen use. Are there other regulatory or code updates that might be most needed to remove barriers for heat pump water heater adoption in restaurants and institutional kitchens?
Yeah, great question. Outside of the health department has a sizing guideline, right? It's not it's not the de facto law, I guess. So restaurants do meet that, but there are ways to kind of have a variance or work your way through that with like engineered drawings and engineered stamp of the system. Now, I mean, when you're submitting plans, you're also going through the buildings department. So, there are likely ventilation considerations as departments get more experience with heat pumps. They'll be kind of reviewing them for not just their hot water, hot water delivery needs or sizing on the hot water sides, but are they ventilating? Can they ventilate the air, or can they use the air appropriately? Additionally, if it's installed outside, like you do have to look at seismic for roof, and certainly, other factors that basically any of the life safety stuff goes through the buildings department, and these units can get pretty big, especially for large restaurants. I remember working with the Cheesecake Factory. They used to have a 2 million BTU boiler with like a 250-gallon tank they put on the rooftops. So structural comes into play as well. And so there's just a number of things that are the buildings department handles that is consistent with all like large pieces of HVAC or water heat equipment. So certainly some familiarity and some potential updates there is needed as well.
Mm-hmm. Thank you for that. And then Tim, if we could have you address the next question, that's asking about thoughts on the use of propane or R32 to gain lower temperature performance at the cost of some efficiency.
Yeah, for technical heat pump or product design reasons, there's not so much standing in the way of using those types of refrigerants. It's really the building codes and mechanical codes. Fire marshals and code officials in the US are not yet comfortable with many of these A2L and A3 refrigerants in the interior of a building.
Thank you for that. I wonder if you're I'll open this up to the entire panel too. I wonder if you're seeing any trends for restaurants and commercial kitchens. Are we seeing them get larger or get smaller? And maybe it depends, but I feel like I'm seeing a lot more really small kind of approaches to commercial kitchens. Um, and so just tell me, does anyone have any thoughts on that? How about you, Richard?
Yeah, that's why I popped back on. That's one I can answer. Yeah, real estate, labor have, they hit, particularly real estate cost hit restaurants pretty severely. And so in the chain world, you are seeing people who are trying to do production in ever smaller spaces. And, an example is the success of Dutch Brothers right now. The coffee, which is just a tiny little space. It's the tiniest of little spots, right? But you can generate a lot of revenue through a small space and a drive-in format. So you are seeing commercial food service sort of looking at their menus. What do they not need? How much revenue can you generate in the amount of real estate you have? Now keep in mind that's the chain operators. For the mom and pops out there, they're typically just beholden, the independents beholden to the spaces they can get into. So I wouldn't say that they're necessarily shrinking so much, but the chain people are always thinking, what can we do, production versus space.
And does this have any impact on the ability to use heat pump water heaters? Is this speak to the likelihood of the increased use of heat pump water heaters in these spaces?
Yeah, it would make sense. Absolutely. Once again, if you've just got less need for hot water, and if you don't have a dining room, a lot of operations are moving to strictly drive through or walk up. Then yeah, you've reduced your sanitation needs some, and everything goes down a little bit. So all your needs go down.
I could add a little bit too, Susan. I mean, generally in the last 10 years, we've seen a big reduction in full service restaurants. Your Chili's and those types of places. If you look around in the Bay Area where we are, there's just not many of those classic restaurants around. And so a lot of times, because of the costs, diners can't eat out and pay those costs, and it costs a lot to operate those facilities as well. So there's been a sizing down to fast casual, and so it's almost like you're opening up. You don't have just like cafe, quick service, full service. You have this fast casual that's like in between, and so there's certainly a big reduction in hot water use when you kind of go into the Chipotle's and other types of facilities like that. And yeah, I think that perhaps hot water use in restaurants has gone down, right? Because of the trends in sizing down food service. So we want to go down much further, of course, with heat pumps, right? That's the goal.
Yeah. But also keep in mind that, we like to talk a lot about restaurants, but that's just one small piece of the entire segment. Universities, hospitals. At the same time, restaurants are getting smaller, hospitals are getting bigger, and senior care is, a massive growth industry, and, all that kind of stuff. So, and those facilities don't tend to be, they need to be a certain size, right? They have to serve their clientele and customers, and they're more institutional. Same thing, business, like high tech, B&I kind of stuff is growing, and same thing, bigger kitchens, which is why we've spent a lot of time talking about the solutions at the small end, the cafe end, but the stuff that Tim's talking about, the ability to bring in multiple split systems and really drop several units on a rooftop and serve the needs of mid to bigger size facilities is really crucial, and sort of the next step, and the work that Amin's doing in right sizing the hot water requirements from a code standpoint is super important, because just like our electrical codes, they're conservatively sized, and that's great when energy's cheap and water's cheap, and and you can afford to be conservative in your sizing, but now it's time to right size, get those systems doing what they're supposed to do.
Yeah, absolutely. And that feels like a good point to wrap. Although I did just get a couple more questions, so maybe with one more minute, we'll try to answer them. And here's an interesting one. There's some uncertainty under AIM right now. How are manufacturers addressing refrigerant transitions for commercial applications? And who would like to take that one?
I could tell you what I saw at the NAFM show when I was there last spring, which is across the board. I saw some people who were way into the future, and they're already crossed the line and have all kind of propane CO2 systems, and other people who were like, no, we haven't really started with that yet. So I was pretty puzzled, or I won't say puzzled, but surprised by the bandwidth of response across. This is the big restaurant equipment show, so I just went to everybody and was querying them all, like, well, what are you doing? Where are you at? Or and ultimately, regardless of the government theatrics, manufacturers and refrigeration manufacturers, they've spent a lot of time and money moving forward with refrigerants, and they're not going to turn around and go backwards. So even if the government tomorrow says, well, we're pulling these DOE standards, and I just went to also a codes presentation, and there just seems to be massive confusion, on it's a true train wreck at the moment at the federal level on what is and what ain't going to happen. So the notion is, keep your eye on the ball and keep moving forward. That's probably what most manufacturers are going to do. There was another quick question about, institutional. You seeing, it really depends. You're right. In a big university, they'll probably still run off a central boiler system. But as these universities move more towards electrification, they may decide to split it out. And also, big institutions like that they tend to do multi-use. They'll drop a restaurant into a campus facility, and that one could be on its own water system. And is there any restaurant market segment that's a good entry point for heat pump water heaters? Probably quick service. Quick service and cafe kind of makes sense. So,
all right. And we're just a couple minutes over time. And I just want to say thank you again, panelists. I think you're superstars. Really appreciate you taking time with us today. And thank you to all the attendees for joining us. I hope you join us for more sessions this week, and I hope to see you on Heat Pump Water Heater Day on Thursday.
Thank you.
Cheers.
Thank you.
Bye-bye.